Hey guys, today we're going to work on the addition of like terms in rational exponents. So basically combining like terms. We've done this before a number of times. The twist that we have today is to deal with positive or negative exponents, or similarly when a variable is in both the numerator and the denominator. So in dealing with these like terms, you can simplify by adding or subtracting the coefficient. And we remember this with any of our like terms that we've done before. So x squared plus 3x, it's a like term because both terms have the variable x, and it's in both terms to the same type, the first type. So you simply add the coefficients. X is always an implied 1, so it's just x plus 3x equals 4. Another way to think of it, you have 1x and you add 3 more x's. How many x's do you have? You have 4 x's. So pretty simple math terms. You can logically think in terms. It's not a problem. Second one, let's do 2x plus 3y plus 5x minus 7y. So this one's a little bit more complicated in that we have two sets of like terms that aren't like each other. So the first one is the 2x and the 5x. They both have the variable x to the first power. You can simplify that by just adding 2x plus 5x. And so that gives you 7x. And then the other set of like terms are the 3y and then negative 7y or the minus 7y. It doesn't matter either way which way you say that. It could be 3y minus 7y or 3y plus a negative 7. They both simplify out the same thing. And you get negative 4. So you would end up with 7x minus 4y for this end. For the third one, 5x squared y plus 3y plus 2x squared. How do we simplify that? Well, we can't. And the reason is it's already simplified since there aren't any like terms. All of the variables have to be represented with the same exponent to make it a like term. So even though the 3y has the y component of that 5x squared y, you still can't combine it because it's different things. So going back to the example, if x squareds are apples and y's are oranges, you have 5 groups of apples and oranges, and then you have 3 oranges and 2 apples. And you can't combine that because the groups are different. So if you have 5x squared y's, you don't know how many more you have with the 3y or the 2x squareds. So it's simplified as it is, even though some of the variables are the same, but not all of the same. And the exponents also need to be the same in order to combine. So very important. Let's talk about like terms with negative exponents. Again, this is where we start getting to something different that you haven't seen necessarily before. We've talked about negative exponents before. We've also talked about like terms before. So this is basically a lesson combining two topics that we've already discussed. Sometimes it can be confusing to see which are like terms when some of the exponents are negative and others are positive. And I give an example here of 5 different terms that are all like terms. So you have ab squared c to the negative 3 b to the 4th is equal to b squared b to the 4th divided by a to the negative 1 c cubed, which is also equal to ab squared b to the 4th over c cubed, which is also equal to a squared b cubed b to the 4th over ab c cubed, which is also equal to 1 over a to the negative 1 b to the negative 2 c cubed b to the negative 4. So you can work these on a piece of paper and make sure you understand to yourself before you go too much farther that all of these are equivalent. Negative exponents simply mean a reciprocal. So to move one of the variables from the numerator to the denominator, you just change the sign of its exponent, and vice versa. To move from the denominator to the numerator, you would also just change the sign of the exponent. So to make these sorts of problems easier when you have to combine these like terms, make all the terms consistent first. You can put them all in the numerator, you can make them all positive, or whatever. Just be consistent. So that way you can easily see what the like terms are. Let's do a couple examples now. We have 4a squared b cubed c divided by a c to the negative 4. And that's plus 4a to the negative 1, all right, 4 over a to the negative 1, b to the negative 3, c to the 5th, minus 7c cubed over a to the negative 1, b to the negative 3, c to the negative 2. So you can see here, let's figure out what are like terms in this. So first of all, we have to just decide what sort of standard format we're going to use. And in this case, we'll just put everything in the numerator. So all of the variables in the denominator, let's change their signs, move them to the numerator, and combine them with variables that are already up there, if possible. So in that first term, you see a squared over a. So move the a up, that's a to the negative 1. And then remember the quotient rule if we're dividing exponents. So it would be a squared minus a to the first. So it would just be a. The b is already in the numerator. There's no b in the denominator. And the c is in both. So let's move that c to the negative 4 up. So we have c to the first power times c to the negative, c to the 4th power. If you move that up, or you can, so if you move it up and it becomes times, then you would add the 1 and the 4 to get 5, the exponents, or you could do c to the negative, c to the 1 minus a negative 4, or c to the 5 power. For the second one, you have 4 over a to the negative 1, b to the negative 3, c to the 5th. So let's move all of those variables to the numerator. There are no variables in the numerator now, so we don't have to combine anything or simplify anything. So just swap the signs on all of the exponents. So you get 4ab cubed times c to the negative 5th. And then minus, remember to keep that minus there. Don't forget the minus sign between the parentheses. If you forget the minus sign, you're going to get it wrong. So minus 7c cubed divided by a to the negative 1, b to the negative 3, c to the negative 2. And so let's move everything up. There's no a's or b's in the numerator as it is. So both of those just become positives since they're already negatives when we move them up. We have a c cubed and we have another c squared we're adding. So that gives you c to the 5th. So that's minus 7ab cubed c to the 5th. You can see the first and last terms are like terms once we simplify this. So they're both a b cubed c to the 5th, whereas that middle term has a different exponent for c. It's c to the negative 5, so we cannot combine them. This is why it's important to make sure everything is written in the same nomenclature, just to make it easier to see which are like terms and which aren't. So we have 4a b cubed c to the 5th, and we're subtracting 7a b cubed c to the 5th, so you end up with negative 3, a b cubed c to the 5th, and then we can add in that 4a b cubed c to the negative 5th. Okay, does that make sense? Let me know in the comments if it's confusing. So let's look at the second example. It's x to the negative 3y over xy to the negative 2 plus 4xy over x to the 5th. In this case, let's do it a little differently. Instead of putting them all in the numerator, let's just make all the exponents positive. So the negatives, any negative exponent, let's move to the, take the reciprocal of it, make it a positive exponent. So in that first one, the x to the negative 3, we can move that to the denominator. And so we already have an x down there. So now we have x to the negative, or I'm sorry, x to the 3 plus x to the 1 in the denominator. So we have over x to the fourth. And then the y's, we have positive y in the numerator and y to the negative 2 power in the denominator. Let's move those to the numerator then to make them positive. So it's going to be y to the exponent 1 plus 2 or 3 in the numerator. So we get that fraction of y cubed over x to the fourth. So pretty straightforward. Now let's do the same thing with the second one, 4xy cubed over x to the fifth. The 4x are also already simplified, they're positive and done correctly. We have we have y cubed over, I misstated that, I'm sorry. We had the x cubed is in the numerator where it should be and is correct. The x over x to the fifth, we can simplify by moving that x down to the denominator. So using that quotient rule, it would be x to the 5 minus 1 or x to the 4. And so that one ends up as 4y cubed over x to the 4. And notice now that these are like terms. So we have 5y cubed over x to the 4. Okay, I think that's it for today, for this lesson. Good luck, and I hope it made sense. Thank you.